Day 28, Honors Physics, Projectile Motion, problem number 30. What makes this one difficult is that you are not given the magnitude of the initial velocity of the golf ball, but you are given the angle. So you'll be finding the components in terms of the actual velocity or the given velocity that we're looking for. This angle here is 60 degrees. I've already done some of the work. I skipped this step, but I'll show you where these came from. Bottom line is, once again, with your vector triangle you see up there with your v sub x, and v sub y at 60 degrees, if you're applying sines and cosines, for example, the cosine of 60 degrees in that diagram is the adjacent leg, which is v sub x, over the hypotenuse, which would be v. So that's why v sub x is v cosine of 60, and likewise why v sub y is v sine 60. I've already plugged those into our conditions for our horizontal and vertical, our standard procedure here. And now we have a lot going on here. Oh, the other thing is, as always, or importantly, you have your point A and point B. Point A is where the release is, but point B I picked at ground level. You could have picked point B at the top of the parabola, which might have made the problem easier, I'm not sure, but this will work. If I pick point B where I did on the diagram at ground level, where the ball is going into the cup, then my S is 0, my vertical displacement is 0. I still have a horizontal displacement of 40 meters, but my vertical displacement is 0, and I also know that v sub f vertically is negative of v sub I. In other words, v sub I, the vertical initial velocity, is v sine 60, as I have shown you on the left-hand side here. But so v sub f, the landing speed vertically of the golf ball, will be negative v sine 60. Now if I start over there, and you might have to play around a little bit, but I'm not sure this is the most direct way to do the problem, but if you look at equation number 3, well, let's try equation number 1. Let's try equation number 1, it's a little bit simpler. In other words, v sub f equals v sub I plus at. There's just a lot of algebra at this point. We've done all the physics, basically plugging in and using algebra now. Bottom line is we have, well, v sub f is negative v sine 60 equals v sub I, which is v sine 60, plus negative 9.8 times t. So that would be basically minus 9.8 times t. Simplifying here a little bit, I'm going to move the v sine 60 to the left. You're going to get two negatives. Well, you're going to get negative 2v sine 60 equals negative 9.8 t. Or in other words, solving for v here, you will end up with v equals, well, it's going to be negative 9.8 divided by 2, which would be positive 4.9. 4.9 t divided by sine of 60. That doesn't look like it's very useful, but it is, because if I go back now to my horizontal condition, the horizontal condition, I'll do that in blue, the one equation I'm going to apply is v equals s over t, and that is then v cosine 60 equals 40 over t, or in other words, t equals 40 over v cosine 60. Or let's just solve that. Let's solve that for, let's make it easy on ourselves. Let's solve that for v. That, in other words, is going to be v equals 40 over cosine 60 times t. There's other ways to do this one. In other words, now I have two expressions for v. They must be equal to each other. So this must be equal to that. In other words, 40 over cosine 60t, 40 over cosine 60 times t must equal the 4.9 t over sine of 60. I'm out of space, but here's what you can do here. You cross multiply, and evaluate for sine of 60, cosine of 60, you're going to have t squared. Just do the algebra here. Cross multiply, figure out the sine and cosines of 60 there, and then finally you'll take a square root, and you'll end up with t. Now, we're not really looking for t, well, but t is very useful, because once you have t, then you can find v from this equation, or the blue equation on the bottom left over here, but that's how you would finish off that problem.